Okay, hello everyone. We are dealing with a problem of learning object poses from synthetic single-channel images. We are training a neural network for this task. We are training it only on RGB images without using depth, and we use only synthetic images for the training. One of the most interesting parts of our work is our proposed solution to the domain adaptation problem between synthetic and real images. And you can see in our evaluation a comparison to state-of-the-art and an evaluation of different loss functions to deal with the problem. We also propose a new markerless dataset for textured objects that is free to use.
Thank you. Hello everyone. So our poster is about camera projector calibration system. So we designed a new system which is featured by a single shot purpose calibration, and we are robust for imperfect planar targets. So the idea is using this struct light and a regular checkboard pattern for calibration, and then finally we have a bundle adjustment module to handle the robustness. So the experiments are on synthetic industrial data. Thank you.
So you know what happened.
Hello, everyone. Today I'm going to present our work, a new view-dependent texture mapping method called DOTS. So basically, VDTM can achieve photorealistic rendering, and it can preserve the dynamic lighting effect. But however, it's very sensitive to error or missing data. So our DOT is trying to create a set of synthetic texture.
Hi, I'm Anna Stanescu, also from the Technical University of Graz, and we have an algorithm that does segmentations of 3D point clouds using 3D geometric primitives. As an input, we get a stream of 3D dense point clouds, and as an output, we get for each frame a set of geometric primitives. The point clouds are already registered in a global coordinate system, and what we want to have is we want to automatically detect the primitives that are outdated, and we have support vector machines classifiers that detect that for us. And in this way, we are able to discard the outdated models and perform a refitting in that region. And in this way, you can see that the scene model can improve over time, so over multiple frames. Thanks.
Microphone.
Hi, everyone. I come from NetEase, China. That's right. We propose an online molecular density concentration system combined with the point cloud and depth, predicted depth. And to solve the scale consistency, we introduced an adaptive loss function to during training stage, and the results show that our method can be suitable for the AI applications. Thank you.
Hi everyone, my name is Nam Zeng Zeng. I'm from Institute of Research and Technology BCom in France. And today I'm glad to show you our paper XYZNet triggers machine learning camera recognition by using a stand coordinate prediction network. In this paper, we propose a hybrid methods combining deep learning and geometric approach through robust camera recognition. Thank you, and see you in photo session.
Hello, my name is Atsunori Moteki from Fujitsu Laboratories in Japan. We developed a visualization method for inspecting manufacturing defects by superimposing CAD data. The defects are highlighted and error value is displayed, so even unskilled workers can check a product effectively. And we developed semi-auto and robust edge-based registration method within a reasonable time in case of the defects. If you are interested in this research, please come to my booth. Thank you.
Hello, everyone. I'm Tejo Chalasani from vSense Group in Trinity College, Dublin. I'm here to present our work on recognizing egocentric hand gestures for our head-mounted AR devices. We do this using deep learning, and we use a combination of CNNs and LSTMs to achieve this. And we encode the ego hand features using CNNs and recognize the gestures in LSTM from the encoded hand features. As we all know, it's data intensive, so we also publish a data set and also a novel data augmentation technique. So to summarize, we have a new architecture, a new data set, and a novel data augmentation technique. Please stop by our booth for further discussions on details. Thank you all for listening.
Hello. Today, is that not you? I'd like to talk. We propose a user interface that expands the workspace of a smartphone by superimposing a virtual touchscreen on a flat surface and allowing the user to touch operation on the surface. The virtual touchscreen is fixed in a layer space, and the user changes the area to be displayed quickly by moving the device, which realizes a large effective workspace. The user can drag the entire workspace by swiping the surface or performing gesture operation in the air, which allows the user to move the object outside the surface or out of the user's reach towards the user. I'm thinking the interface will solve the problem of smartphones that occur due to their small screen size. Thank you.
Hello, this is Ujin-jo from Quest UBR Lab. We propose a method that can effectively track the 3D hand poses when the hand is grabbing on a real object. Most of previous studies often fail to track the object grabbing hand. They utilize whole depth input or segmented depth input, which the object area is removed, like in those figures. So we focus on that removed region of the hand, which probably contains a part of the hand behind the object. So we made a hypothesis that reconstructing reliable depth data in those occluded regions can improve the performance of the hand tracking. Thank you.
Hello, I'm Seiichi Nezaki from Saitama University in Japan. We propose a system that can reproduce material appearance of real objects using a mobile augmented reality. Our proposed system allows the user to manipulate a virtual object whose model is generated from the shape and reflectance of a real object using his or her own hand. The user can obtain the perception of materials from changes in gloss and varnish of the object by rotating and seeing the object. If you are interested in our work, please come to our poster presentation. That's all. Thank you.
Hi, I'm Caterina Battisti from FBK Trento. Interacting with augmented objects in mixed reality would be more realistic if we could use our bare hands. The main problem is occlusion needs to be accounted for. So our solution is to associate the depth of the hand with the appearance of the hand in the image. And as a result, you can see some examples here, or you can come to our poster to try the demo. Thank you.
Hi, my name is Jesus Jimeno from the University of Valencia. And I think maybe all of you have tried to create an application of augmented reality to see the interior of a real object. For that moment, our proposal is to think about if the hollow geometry is simpler than the rest of the object geometry, please try to use the hollow to see through instead of using the rest of the object to create the occlusion. Thanks. I will be proud to explain this to you in the poster sessions. I will see you in a second.
Hello, my name is Nate Phillips, and today I'll be talking about my research in perception and augmented reality at Mississippi State University. In particular, my research deals with the relationship between depth perception and visual cues, such as accommodation, convergence angle, and contrast. However, unfortunately, most AR displays do not allow the adjustment of each of these properties. As such, we have created our own optical apparatus on a tabletop called a haploscope and present a schema for its calibration. If you're interested in this research or are interested in designing and building your own haploscope, please come see me at poster 1068 in session A. Thanks, and enjoy the rest of the conference.
Good afternoon, everyone. I'm Sota Shioman from Osaka University. Generating synthetic images is one of effective solutions for camera localization and variable lighting conditions. However, synthetic images cannot perfectly copy the actual view. The gap between a real and synthetic images can cause degrees of localization accuracy. To solve the problem, we introduced a neural network named RES that converts a real feature into a synthetic feature. For more details, please come to our poster number 1069. Thank you.
Hello again. This is Gisha from Valencia. I think collaborative applications are great because the real world is collaborative. But if you go to real world, you will find many different kinds of users with different kinds of devices, so different immersion levels. In this very short article, we are just creating a system to mix different levels of immersion, high immersive, medium immersive, low immersive, with VR headset, with a tablet, and with PC. If you want to see that, I will be at the poster. Bye.
Hi, everyone. So we know that the main goal of calibration in optical see-through near-eye displays is to estimate the proper projection matrix that can project 3D world points onto the image plane of the display. So in our work, we are proposing an automatic and accurate method for calibrating OST near-eye displays suited for near-eye displays with infinity focus. So if you're keen to know more, please come at my poster or at the demo session at TUM Open House. Thank you.
Hello, my name is Shingo Okeda. I'm from Japan. Nice. There is a lot of applications in the world, but almost applications when the user wears head-mount display, the image change suddenly from real to VR. So, So we propose a novel real virtual transition technique that preserves the sense of conviction about reality in the virtual environment. So I prepared a simple demonstration. So please come to the practice. Thank you very much.
Hello, our work uses dense scene reconstruction for remote collaboration. A local user can reconstruct the scene while working by using our HMD. And a remote expert can simultaneously navigate the scene in 6 degrees of freedom. The expert can also place 3D annotations, such as 3D drawings. And furthermore, the expert can also use the reconstruction to segment objects from the scene and reuse those objects to show how a specific tool or object can be used and should be used. Make sure to also check out our demo. Thanks.
Hello, I'm Brian Williamson, University of Central Florida. Our research focused on tracking during extreme agile movements like you might see during a physically active video game. We found that single sensors tended to have large tracking errors. So we used a sensor array, sparse feature detection, and greatly reduced our localization errors. Also, all of the data that we recorded is available for download. The link is on the poster. Thank you.
Hello, this is Chen Yuan from Purdue University. we have developed a system for telemetry through AR. On the left side, in the Mentee system, an overhead camera captures and sends the surgical field to the right side to a real mentor, who annotates it with touch-based gestures. Those annotations will be sent back to the left and display directly via a HoloLens. In this way, the annotations will be directly anchored to the surgical field with correct depth perception. We have validated our system in a user study with 20 participants performing lower limb fasciotomies. Come by our poster to learn what we found out.
Hello everybody, my name is Michael Priller from Gloucester University of Technologies, and in my group we're building collaborative mixed reality applications, and we would like to know how people interact with them. However, from camera feeds or individual device feeds, this is difficult, and so we built an analysis tool that animates all of this, has some pretty cool features, which you can see at the poster. Among these, it gives you directed gaze cues, fields of use, AR device and real fields of use, multi-room support. And if you're interested in that, I have 2 case studies with me. Can give you a small demo. I'm all the way back on the left-hand side of the posters.
Hello, I'm Ramya from TCS Research India. We tried to answer the question if we can use a fingertip to trigger the virtual buttons and without using depth information. This is particularly useful in frugal head-mounted device, which is basically Google Cardboard with a smartphone, which is ubiquitously available. And we have a small demo as well. Our contributions are mainly a neural network architecture. Given a hand in the field of view, can we regress the fingertip accurately and trigger the virtual button, so on. Please visit our poster 112. Yeah. Thank you.
Hello, my name is Rafael Radkowski. I'm from Iowa State University, and I'm presenting here a piece of system engineering, something that one of my former grad students did. We have multiple Kinects in our lab, so 4 in total. We can obtain point clouds from them, track objects in this point cloud, and then what we did is we integrated the HoloLens by just submitting the pose information to the HoloLens to get a perfect registration, and what the paper talks about is the calibration, so how my grad student calibrated this. It's a little bit tricky, but we can basically move objects and where HoloLens walk around and the objects are registered. And yeah, if you want to learn more about that, please find me in the poster session. Thanks.
Hello, everyone. I'm Xue Yingqin from Shandong University of China. And please imagine what happens if this pedestrian is working and some virtual characters were interaction with him. So we need the 3D spatial occupancy of this pedestrian. Please come to us to see how could we make an appearance manifold marker to represent this object compactly, and then so that we can track the target and find the trajectory and the 3-dimension occupancy, and finally, okay, we can make the virtual characters interact with the
Hello, I'm Masahiro Nishizawa, Yokohama National University, Japan. I'll talk about a precise color estimation technique for dynamic projection mapping system. In some AR systems, including color compensation or appearance moderation, the original surface color should be captured in real time. However, unlike video see-through AR, captured scenes are already moderated in a projector camera system. We developed an online reflectance estimation considering the non-diagonality of a reflectance matrix by using knowledge of various surfaces for further accuracy. Thank you.
Hello everyone, my name is Ilya Makarov, High School of Economics. We present the problem of depth map super resolution. So we created UNet-like architecture of a deep convolutional neural network and adjusted with adversarial component, achieving a state-of-the-art quality of depth times 8 super resolution, and also achieving better structural quality of obtained full depth map. See you at the poster session. Thank you.
Hello, everyone. So we've all had AR or multi-sensor systems that didn't work or we weren't proud of at all. The main reason for this is that we register things or calibrate things every day and we get tired of it. Now this requires care and love, but we don't have that all the time. Now what if I tell you that with gamification you can make even these things less tedious and even enjoyable to a certain degree? So we observed this in many users and tried out a lot of things, and we think that we've discovered a lot of elements that you might be interested in. So see us there, and I think I was the last one, so I pass this to the left side. No, we have a... All right, it's fine.